You can work systems of equations with more than just two variables, although on the test you'll probably just have to do two by hand. You can use three variables, x, y, and z, and you can use substitution and elimination. We'll also see that the matrices methods are pretty nice for these as you get more and more variables. For substitution, you take one equation like the first one and solve for one of the variables. I'm going to solve for z. So I'm going to move z over to the right, add z to both sides, and add 1 to both sides. So x plus y plus 1 is going to equal z. Now I'm going to put that into the second and third equations. So the second one becomes 4x minus 3y plus 2, well, z is going to be x plus y plus 1, and that equals 16. The third problem, I'm also going to plug this in for z. 2x minus 2y minus 3, well, z is x plus y plus 1, and that equals 5. Now, what you do is you work this out so you can collect the x's and the y's. 4x minus 3y plus 2x plus 2y plus 2 equals 16. There are 6 x's and negative y, and we're going to subtract 2 from both sides and get 14. For this one, see, 2x minus 2y minus 3x minus 3y minus 3 equals 5. Pen is running out of ink. So let me grab a different one here. So there's 2 and that's a negative x. Negative 2 and negative 3 is negative 5y. And I'm going to add 3 to both sides and get an 8. But now we have a problem like we had just before, just in x and y. So if we want to use substitution, let's solve for the x on this one. So this one's going to be negative 5y minus 8, subtract 8, and then add x to both sides. I'm going to plug that in for the x and get 6 times x, which is a negative 5y minus 8, minus y equals 14. So this is a negative 30y. This is a negative 48 minus y equals 14. So negative 31y equals, if we add 48 to both sides, that's 62. Divide by a negative 31. Y is equal to a negative 2. Plug that negative 2 in back here. Negative 5 times a negative 2 minus 8 equals x. So this is positive 10 minus 8 equals x. So positive 2 is equal to x. Take the x and the y, plug it back into one of these original. I'm going to use the first one. So 2 plus, I guess, a negative 2 minus z equals a negative 1. So these cancel. Negative z equals a negative 1, so z is equal to 1. So our system of equations, now 3 variables, do it usually alphabetically, x, 2, y, negative 2, z, 1. And you can use substitution or elimination and solve 3 variables. But we're going to find out that our matrices might be better for these situations. What in the heck is a matrix? Well, Matrix is an ordered arrangement of rows and columns. A11, A12, that's not 11, that's not 12. A13, this gives you the row and the column. And we might be able to go up to A1N. So there are N columns. A21, A22, A23, go up to A2N. And you can keep on going until you get to AM. That's the row, first column. Row M, second column. Row M, third column, up to row M, N column. So this is a rectangular array of elements, usually numbers. We use uppercase to name these usually. But this is an M by N matrix we're going to call A. So how do you solve these? Well, we're going to use an augmented matrix method. Let's just get a 2 by 2 first. See, 3x minus 4y equals negative 6. 2x minus 3y equals negative 5. It's important to get the x, the y equals constant, because this is going to be our matrix, and we use the x column just with the coefficients 3 and 2, the y column just with the coefficients negative 4 and negative 3, and we'll augment that with this equals column negative 6 and negative 5. This is called an augmented matrix. And what we're going to do is get on our calculator and put this into our matrices on the calculator. So once you have your calculator on, you do second matrix. That's above the x to the negative 1. And you go over to edit. Our matrix, we're going to call it A. They call it A here also. This is a 2 by 3 matrix. Let me put that here. 2 rows, 3 columns. So when we edit A, we can put in 2, enter 3. And it'll give me the 2 rows and 3 columns. You might have to zoom in to see this. You put in the numbers, you go across the column as you're doing this. 3, negative 4, and negative 6. They don't put that dot, dot, dot there. 2, negative 3, and negative 5. Once you have that in, we're going to put this in what they call row reduced echelon form. Goodness. How do you do that? Well, you get out. You quit the matrix. You go back into the matrix. You have to get out, otherwise it starts putting stuff in there. And you go over to math, that middle one, down to where you see RREF, row reduced echelon form. Press enter. Now you got to tell it which matrix you want. Go back in, second matrix. Now the names come in. Matrix A, close the parentheses. When you press enter, you get 1, 0, 2, 0, 1, 3. It is still an augmented matrix. This is still the x column and the y column and the equals column. But what does this first row tell you? X plus 0y equals 2, or x equals 2. 0x plus 1y equals 3, or just y equals 3. And you've solved your system of equations. We can do this for larger systems also. Let's go back and do a system. Let me write it down. X plus 4y minus 3z equals -8. 3x minus y plus 3z equals 12. X plus y plus 6z equals 1. So this, we're going to put this in a matrix. Second matrix. We're going to go and edit. Might as well use A again. But now this is going to be 3 rows and 4 columns. A 3 by 4 matrix. It's going to have a 1, a 4, a -3, and a -8. Remember, you got the X, the Y, now the Z column, and the equals. 1, 4, -3, -8. The 3, -1, 3, and 12. The 1, 1, 6, and 1. Second quit to get out. So your row-reduced echelon form, doesn't matter how big it is. You can use then second enter to bring things back. And we'll do the row-reduced echelon form for A, which is where we put this. When you press enter, now you're getting these values. X equals 3. Y is equal to, so -2.6667, or -2 2/3. And Z is 0.111111. Repeating. Now, if you want this to be fractions, you can do that. Do math and this frac thing. It'll take the answer and change it to fractions. So you get the 8/3, that's an improper fraction, and the 1/9 is the 0.1 repeating. Have to remember that. 0.1 repeating is 1/9. So you can do this up to, and I've done it once, 99 variables, at least. And maybe this just worries about the memory and doesn't worry about the other stuff. That's all we're going to do, I guess, for ours. There is something in 12.2, but I think we'll not worry about that for this. This is a good way to do it, and it's useful. If you get into discrete mathematics or linear algebra, you'll use some other methods also. But we're done with 12.1 and 12.2. You should be able to do your assignment.